Good morning, everybody. Welcome back to lecture number 46, which is the last lecture. Hopefully, you will try to finish. متأخرين. So, today we will solve an example of the diode rectifier, okay? So, center tapped rectifier, we have 23,000 volt, RMS, A is 10, so what is the voltage here? 230, صح? A is 10. So, here we have 230 over 2, here we have 230 over 2. You agree with me?
Yes.
Both of them 230, عشان هنا ratio 10. So, write and plot time domain expression for Vs. طبعا هنا we have diode 1, we have a resistor 10 ohm, we have diode 2. So what is Vs? Vs is the square root of 2 times 230 over 2 sine omega t. How we plot it? Here we pi, here we have 2 pi, and this is Vs. You can put here the number is square root of 2, 230 over 2. So what is V output? V output is the square root of 2, 230 over 2, absolute value of sine omega t, because we rectified, صح? So V output is Vs peak is 230 divided by square root, divided by 2. Okay? Pi, 2 pi. You agree with me? So what is I load? I load is V output over R, which is square root of 2 times 23, because 230 على 10, 23, to absolute value of sine omega t. So I load is what? Square root of 2, 23 على 2 peak حقها. تمام؟ Clear? Calculate the power through the resistor. So power is what? V output times I load, which is what? Square root of 2, 230 over 2, absolute value, sine omega t, times square root of 2, 23 over 2, absolute value, sine omega t. You agree with me?
Yes.
If you do the math, it is I square R, or V times I, or V square over R. Both will give you the same answer. So calculators. So you should get 2, 6, 4, 5, 2, 6, 4, 5, absolute value, sine square of t. What? Even if you do I square R, if you square this times R, you should get the same expression. Or use V square over R, you should get the same expression. Okay? Try it. What is VDC? VDC is 0.6366 Vm. But what is Vm? Vm is you go to the drawing, is the peak of Vs. Vm is the peak of Vs. So what is the peak? Is square root of 2 times 230 على 2 volts. So VDC is 0.6366 times square root of 2 على 2, 230. Was 103.53 volts. So what is IDC? To get, so this is VDC. To get the DC power dissipated on resistor, I can use PDC, either VDC square over R, or VDC IDC, or IDC square times R. Remember, this is single phase, okay? So if I use this expression, then I should have 103.53 squared over 10, which is 171.91 watt. So clearly, the average value, or the RMS value of this expression is 1071. Or I can get IDC, which is 107 over 10, 103.53 over 10, and I square it, and I multiply it by 10. I should get also the same expression. Okay? Clear? Any question about it? Any question? Yes?
كيف تجيب 0.6366؟
هذا من السلايدات. This integration. If you integrate 2 over t from 0 to t, what is t? T is 1 over 60. Here, time period. 2 over 160 from 0 to, what is t over 2? Is 1 over 60 divided by 2. They have 1 over 120. If you integrate from 0 to 120 with respect to time, this time expression, you put the right Vm, you should get 2 over pi Vm. لأن الVm تطلع برا الانتجريشن حق الساين اوميجا from 0 to half period is 2 over pi. Clear?
Yeah.
Now here is a more challenging question, and I'm rushing it because we have too much material. Okay? We're late. تأخرين في المنهج. And I have to teach you these things. Otherwise, I'm not doing my job. For a center tap diode rectifier with thyristor, we have VRMS is this, R is this, A is 10, and we have firing angle come 60 degrees. Calculate VDC and IDC. Everything is the same, except I have to go back to integration. Now, I can tell you, I'm not going to ask you this in the exam, okay? Let him study first. Okay? This is just for your own knowledge. I'm not going to ask you. I'll probably ask you the regular diode rectifier, but how to solve the thyristor? What is the original equation? VDC is 2 over t, integration from 0 t over 2, Vm sine omega t dt. You agree with me? But here, instead, from 0, we have, instead of 0, we integrate from 60 degrees to 180 degrees and then 2 over t. But the limits here are a function of time. So 60 degrees correspond to 60 over 360 times the time period. What is the time period? 1 over 60 hertz. 60 over 360 divided by 1 over 60, which is 1 over 360. So we integrate, this is wrong, VDC is 2 over 1 over 60. We integrate from 1 over 360 to 1 over 120. This is actually 2 over t. T is 1 over 60. Of, what is a VM? Square root of 2, 230 divided by 2. Sine omega t dt. You do this integration, you should get VDC. IDC is VDC over R, or 10.
So
Yes.
مو 2 over t المفروض تساوي 120 مو 1 over 120.
2 over 1 over 60. 2 over t هذه
Yes 120 مو over 1 over 120.
هي تي اوفر 2 المفروض.
Yeah, you're right. 2 yeah, yeah.
لو رجعت تي اوفر 2.
Like that.
Yes.
So I don't know how to do it, but what I know is I think I'm trying to do it, which is 2 over 160 is what? 120 times square root of 2, 230 over 2, and then 1 over omega, which is 1 over 2 pi 60 times minus cosine of 2 pi 60 over 120 plus cosine 2 pi 60 over 1 over 360. And then you do it. Okay? Power DC is VDC times IDC, or VDC square over R, or I square DC times R. Can you do this by yourself? Not gonna ask you in the test, but try to do it. Okay? What's the integration of sine? Minus cosine. So it's minus cosine omega t, minus plus cosine omega the other t. And whoever is doing it, that will be awesome. Clear? So enough about that. Let's go to the rough example. So here we have E360 system example. What is this system example? This is integrated problem 1 of transformer and transmission lines, VIP. 6 heads, 3-phase, 220 kilometer line delivers 60 megawatt of power. So 60 megawatt of power load at 230 kV and power factor of 0.9 lagging. The line has those parameters. Find the pi model VS and IS. So let's do it. Calculators. So what is VR? 230 over square root of 3 kilovolts, which is 132.79 kilovolt and 0. What is IR? Is P over 3 VR cosine of theta, which is 60 megawatt over 3 times 132.79 kilo times 0.9. you should get 167.34. And what's theta? I is theta V minus theta, which is 0 minus cosine inverse of 0.9. Minus 25.84, no, plus. Okay? Theta equal theta V minus theta I. So what is theta I? Minus theta. What is theta?
So
Is it lagging?
اي لا بالضبط.
So it should be minus, صح?
Yes.
So what is Z? 220 times 0.04 plus J times 2 pi 60 times 0.85 million. .8 plus J times 70.5 ohm. What is Y? .244 times 10 minus 4 J Siemens. Agree with me? We check. Is it correct? Calculators. I think it's wrong. 0.015 times 10 to minus 6 times 2 pi 60 times energy. Ten to minus 3, صح؟ صح؟ Correct? So, what is in A? 1 plus zy over 2. Point 9569 plus 568 times 10 to minus 3. J, B is Z, C is what? Y times 1 plus ZY over 4. خلينا بس أتأكد من واحد. Yeah, it's this expression. So y is 1.247 times 10 minus 3 plus 0.0219 J. Okay? So A has a unitless, B has a unit of ohm, C has a unit of Siemens. Okay? So, any question? So, you can go to your lecture, but I think I have to stay unless Dr. Salam comes, okay?
ما في class.
My class, so we have to stay, we have to finish this exam. Okay? But let me verify I got the A, the B, the C, that's correct. So we got the A. I think we got the C wrong. We got the C wrong. What's the formula of the Z? The C? C formula is Y times what? I think we got the C wrong. 1.24 J. Yeah, we got the C wrong. That's the proper C. Minus 3.404 times 10 to minus 6 plus J times 1.2167 times 10 to minus 3 Siemens. So, what is Vs is AVR plus B IR. What is it, A? Point 9569 plus J times 5.360 times 10 to minus 3 times 132.79. Plus IR B 8.8 plus 70.5 J times Li, which is 167.34, angle minus 25.84. So we should get a Vs to be 133.961 angle 4.59 kilovolts. You have to do this, Shabab. I'm going to ask you this in the exam and you'll get 0 if you don't study. Okay? What is it? IS is CVR plus DIR. What is a C? C is 3.404 10 to minus 6 plus 1.2167 J plus D, which is 0.9569 plus 1.360 times 167 plus 1.9. So C is negative. C times 132 plus D trying to check IS to become still getting it wrong. Okay, so IS is 171.24 angle 32.73 amps. So we are done with 1 point. What is eta 1? Eta 1 is P output over P input times 100, which is 60 megawatt, over what is P input? 3 Vs IS cosine theta Vs minus theta IS, which is 60 over 3 times, take the magnitude, 133.961 kilo times 171.24 times cosine of 4.59 minus 32.73. We should get 99.01%. Okay. Okay. You get 99 or 98, 98.9, something like that. Let's say 99%. Okay? Three 20 megawatt single phase transformer. 3 times 20 come 60. But do they satisfy the design? Yes. 13.8 to 230 kV. 230 kV هو line level, line to line. So this transformer is before ولا after? Before. So 13.8 over 230 kV step up single phase transformers, one per phase constituting a 3-phase transformer, are connected to the sending end of the line, of the transmission line. The parameters of the transformer are given, referred to primary. We have R1 equal to R2 prime 0.0237. X1 equal to X2 prime is 0.237. R2 is this, Xm is that. So is this circuit 1 or circuit 2? Or circuit 3 transform? This is circuit 1. Under operating conditions of the transmission line, so we connected transformer على line. ايش يصير لما اسوي connection؟ يصير ال V secondary حق الترانسفورمر هو نفسه ال V sending حق اللاين. Let's draw the circuit. Okay? So what is the original circuit? The original circuit is I have a pi model. Here I have Vs صح? And then here I have what? Transformer. Vs. Here we have X2, R2, transformer, JX1. Here I have a parallel branch, RC, JXM, R1. You agree with me? But can I solve it? I have to refer everything to primary. So how to refer it to the primary? Well, I have to reflect the VS. ارسم انا دائما مربع. Why ليش ارسم مربع؟ معناته reflection. لما ارسم مربع, what is the voltage here? VS prime, صح? Here J, X2, R2, JXM, RC, JX1, R1, here I have VP. So what is the voltage here? انتوا متعودين عليه كده. JXM, RC. What is the voltage here? EP, صح? So I can do KVL here. So to get it EP is VS prime plus I2 prime times R2 plus JX2 prime. You agree with me? So what is VS prime? VS prime is VS over A. No, it's AVS. لأنه كذا VS prime over VS equal A. M primary over secondary equal ratio of primary and secondary. Go back to slide. So what is it A? 13.8 over 230, step down. What is it VS? 133.3.
تسوي استباق.
لا يا أخي مكتوب هنا. Yeah, step up. Sorry, step up. Step up. معناته ان الفي اس برايم حتصير كبيره ولا اصغر من في اس؟ اصغر، لانه ريفير على البرايمري اللي هو ريفيرد على برايمري لو فولتج. كم كان الفولتج حق في اس؟
132.
لا 133. Remember 0.8
133.961.
forward. كم 0.961? كيلو. So we will have 8.03766 angle 4.59 kilovolts. What is I2 prime? Is IS over A, صح? Which is IS? 171 angle
171.24 and 32.73.
divide by A, which is 13.8 over 230. 171 point come? 2
0.24.
angle 32.73 divided by 13.8 divided by 230. So you should get 2854 angle 32.73. So what is EP? Take this answer times 0.0237 plus J, don't forget the J, 0.237, plus the VS prime, 8.03766 angle 4.59 kilo. So it is 7,803 angle 9.208 volts. This is 7,000. So now we calculate EP. Okay? اللخبطة وين تصير؟ اللخبطة in how to integrate both systems. We still have to calculate all these quantities. So hopefully in the exam I will ask you up until EP, okay? Hopefully nothing after. But what is I1? I1 is I2 prime plus IM. What is IM? IM is EP over the parallel combination between RC and JXM. So what is RC parallel with JXM? Is 1 over RC plus 1 over JXM. And let's calculate it. 1 over 1587 plus 1 over J times 476. Don't forget the J, okay? Will be 130.98 plus 466.71 J. So EP over that come يطلع 7803 angle 9.208 divided by this. We would have I1 to be 17.11 angle minus 64.09 amp. So what is I1? Is answer plus I2. 2854 angle 32.73. So you should get something closer to 2852 angle 32.39 amp. So what is V1? Is EP plus I1 times R1 plus JX1. So answer times R1 10237 plus J times 0.237 plus 7803 VADP angle 9.208. So V1 is what? 76 to 6.65 angle 14.08 volt. This is VP, not V1, V prime. So we calculated VP. See how did we start? We started from here. We ended all the way here. هذه jam. It's rough, I know. But that's how you to think as an engineer. Nobody will tell you analyze the transformer. They'll connect everything together. So, what is the voltage regulation of the transformer? What is the voltage regulation of the transformer? VP minus Vs prime over Vs prime, right? Take the magnitude 7626 minus 80367 divided by 8.0376. This is key. 7626 minus 8037, which is maybe minus 5.11%. Calculate the efficiency eta 2 of the single phase transformer. Note that P output of the transformer is same as P input of the line. شغال؟ Take photos, take photos. What is the P input حق الترانسفورمر؟ So note that the P out of transformer is P input of the TL divided by 3 لأنه single phase. صح ولا لا؟ line 3 phase. What is the input حق transformer? It is V input, VP times IP or I1 times cosine of theta VP minus theta of I1, which is what? 72 is 2 divided by what is I1? 285 2 cosine of 14 minus 32.70. Maybe you'll get 20.583 megawatt. So what is the P output حق the transformer? You can calculate it actually using the P input حق transformer line PN TL divided by 3. I think it was 60.6 divided by 3. So you should get 20.2 megawatt. So what is eta 2? 20.2 over 20.58. You'll get maybe 98.15%. So what is eta 3 overall system? It's eta 1 times eta 2, which is 98.15 times 91.01. So you should get, roughly speaking, 97% efficiency of this system. Clear? Clear how we did the calculation? This is a rough example. Okay? Hopefully this example shows you how to clear? طيب أتمنى أنكم استمتعتم في هذه المادة وفرصة سعيدة عرفت عليكم. أشوفكم إن شاء الله بالفاينل والتوفيق إن شاء الله.
جزاك الله خير.